Honors Math 9 to our first day of virtual learning. So before we went on this break, we were dealing with exponents. And reminder with exponents, if they have the same bases, you add the exponents. So x squared times x to the 5 is x to the 7. If you're dividing with the same bases, so x to the 7 over x to the 10, you subtract them. So 10 minus 7 is 3, so it's 1 over x3. And if we raise a power to a power, y to the 7 to the power of 2, it's y to the 14th. All right, so today we are going to talk about rational exponents and radicals. So the radical sign looks like this. Okay, the radicand the expression under the radical sign so that would go right underneath there. And the index, it's the degree of the root. So if you have something n roots of a, this is the radicand. This is the index. And that is the root. So we have done simplifying radicals. We've done this before. So example 1, if we are doing the cubed root of 125, this time we have to make groups of 3. So if I have 125, we know that's divisible by 25, goes into there 5 times. 25 is 5 times 5. Since we're taking the cubed root, we have a group of 3 5s. So one group comes up on the outside and there's nothing left. So a rational exponent is an exponent that is a fraction. An exponent that is a fraction. So the numerators, that's going to be the power, and the denominator, that's going to be the index of the root. So if we have something like a to the m over n, that is the same thing as saying the nth root of a to the m. That's the biggest thing we're going to take away from this. So example. So example number 1. We're going to write each exponent in radical form. We're going to write each exponent in radical form. So our first one, we have 8 to the 2/3. B, we have 12a to the 2/3. And then C, we have 2x to the power of 5 over 6. This denominator becomes the root, and the numerator becomes the exponent. Now we can continue to simplify. 8 squared is 64. And now we're simplifying the cubed root of 64. So over here I'm going to do 64. It's 4 and 16. 4 and 4. I notice that I have 3/4. So this fully simplifies to just the number 4. This one, 12a to the power of 2/3. This 12 has an exponent of 1, so since it's not a number that has to be written as a fraction, it's going to stay exactly the same. This a is going to turn into the cubed root of a squared. And again, we can't simplify that because we only have two a's and we would need a group of 3. In this case, with the parentheses, both of them are being raised to the power of 2/5. So I'm first going to write it as the 6th root of 2x raised to the power of 5. Then I'm going to distribute this 5 to both of them. So it's the 6th root of 2 to the 5th, x to the 5th. All right, example number 2 is we have to write each radical expression in exponential form. So this is doing the reverse of what we did in example 1. So this is going to become the numerator and this is the denominator. So be 3/5. This one, because there's two different terms here, that 1/3 is going to go to both of them. So it's going to be 27 to the 1/3, x to the 5/3. And then if you always have numbers, you always want to try and simplify it. Do we know what the cubed root of 27 is? Yes, what multiplies by itself 3 times to get to 27? The answer would be 3. So x to the 5/3. And this one, so there is no root written in this example. So if there's no root written, there's an invisible 2, meaning square root. And this is going to go to both of these terms. So since these are in parentheses, we're first going to write 4y, keep it in parentheses, to the power of 5/2. Then we can distribute that 5/2 to both of them. So we're going to have 4 to the 5/2, y to the 5/2. And this one, we're taking the square root of 4, which is 2, and then raising it to the power of 5. So 2 to the power of 5, y to the power of 5/2. All right, example type number 3, we're going to simplify each expression using the properties of exponents and then write the expression in radical form. So just like before, if they have the same bases, here's an x and here's an x, you add the exponents. So if you can't really see it, it's x to the 2/3, y to the 1/4, y to the 1/2, x to the 1/3. So when you combine them, 2/3 plus 1/3 is just x to the 1. 1/4 plus 1/2 is y to the 3/4. So that's our first answer when we simplify it. And now we have to write them in radical form. X you can't write as a radical because 1 does not have to be written as a fraction. And then we're going to do the 4th root of y to the power of 3. So for this example, we're going to have two different answers. Okay, part B says 2 times x to the 2/5 times 3 times x to the 9/2. So again, since multiplication, we can multiply in any order. So 2 times 3 is 6. X to the 2/5 times x to the 9/2 is going to be x to the 49/10. And then we're going to write it in exponential form. So this is one answer. The other answer, 6/10th root of x to the 49. We could simplify that, but we're just going to get to the habit of going from one form to the next. This next example, can't see it here. See? Again, power to a power, we're going to multiply it. So it's a 3/2 times 3/1 is 9/2. That's our first answer. Writing it as a radical, the square root of a to the 9. Part D. Again, for this example, there's no exponent for the 1. So I'm going to distribute the 1/2 to both of them. So it's going to be 2 to the 1/2, x to the 3/10. That's our first answer. And then we're going to write it in radical form. Square root of 2 times the 10th root of x to the 3. Notice you cannot write both of the 2 and the x in the same radical because the root is different. And here we go with part E. Again, I'm going to distribute this 10 to this one. So a to the 1/2 to the power of 10 is going to be a to the 5. I'm going to distribute this 3 to all of them. Remember, if there's no exponent written, there's an invisible one. So we're going to have 4 to the 3rd, b to the 3rd, and then this times -2/3 is a to the -2. Then I'm going to continue to combine my a's. So our final answer is 4 to the 3, a to the 3, b to the 3. We're now going to continue some of our other properties of excuse me, exponents. If you're subtracting or you're dividing, you're going to subtract them. So 3/4 is bigger. So 3/4 minus 1/2 is going to be 1/4. So x to the 1/4. And then again, we still have to write it as a root. So it's going to be the 4th root of x to the 1. Letter G. Y to the 5/2 over 2, or y to the 2nd. Again, 5/2 is bigger, so 5/2 minus 2 is going to be y to the 1/2. Simplified in exponent form, then converting it to radical form, the square root of y. And then again for H, we're going to want to distribute that 3 first to the top and to the bottom. So we're going to have x to the 6/5 over 5 to the 3rd. That's one of our answers. And then writing it in radical form. The 5th root of x to the 6 over 5 to the 3. And last but not least, I am first going to simplify inside of here first. So I have 5. I'm going to do 3/4 minus 5. And that's going to be a to the power of -17 over 4 to the power of -4. So now when I raise a power to the power, I'm left with a to the power of 17. And since 17 doesn't have to be written as a fraction, I am done there. I cannot write it as a radical. Our last example is to write each expression in exponential form and then simplify if possible. So I'm first going to rewrite them all with just exponents. So this is going to be x to the 2/3 times x to the 1/3. So that's the first part. I wrote them in exponential form. And then simplify, 2/3 plus 1/3 is just x to the 1. Same thing with part B. We're going to have y, the cubed root of y times the cubed root of y squared times the cubed root of y to the 4th turns to y to the 1/3 times y to the 2/3 times y to the 4/3. And when you add them all up, you get a total of y to the 7/3. But then we have to write that in exponential form. So it's the cubed root of y to the 7. But then, oh, no, we don't have to do that. We're done. And the last one, part C, my bad. Part C, we're taking the square root of 2x to the power of 4 divided by the cubed root of x to the 6. So I'm first going to rewrite 2x to the power of 4. This is to the power over 2, because this is the same thing as raising it over 2, over x to the 6 over 3. Simplifying it, I'm going to have 2x to the power of 2 over x to the power of 2. Remember, when I raise things in parentheses, it has to go to both of them. So we're going to have 2 to the power of 2, x to the power of 2, over x to the power of 2. Those x's will cancel, and we're left with 2 squared, which is just 4. Awesome job, guys. You completed your first lesson.